situation that we have a higher, what the dual fuel system have a higher electric efficiency, gas auto system general have a higher thermal efficiency. So the thermal efficiency is heat in form of hot water from the CHP or from the exhaust gas. A big pro for gas auto technology is we don't have an additional fuel source as we have in a dual fuel system. So we don't need additional fuel, storage and so on. So we can use the pure biogas, natural gas and so on to operate the system. And the big benefit is you get so many different manufacturers for a gas auto system. It's nothing special actually. So there are many CHP manufacturers outside. Okay, let's go to the contrast. Over. Okay, what is negative? The positive is the higher thermal efficiency. Now we have a lower electrical efficiency. In the meantime, there are different technologies outside that the gas auto system already can get a higher efficiency as well, but not like a dual fuel system. If we have to heat up a digester or the plant, especially in the startup phase, the gas auto system cannot run because there's no gas, biogas available. So we need either a different source of gas, natural gas, LPG gas, or a separate heating system that we can heat up the plant until we get proper gas production from the digester. So special for startup or ramp up the digester, we need additional heating source. As well, the negatives is, as I mentioned already, is on weak gas. The gas auto system on weak gas get already problems below 45% of CH4 content. So there is the point where the spark plug in the combustion chamber cannot ignite properly the biogas anymore because the energy content is too low. So it will not ignite properly, the flame speed is too low, and the ratio of oxygen, so the lambda value, we will go through that later on as well, must be controlled all the time, and that's very difficult with a low CH4 content in the gas. And it's very difficult to operate a gas auto engine on weak gas in island mode. So without natural grid, to operate the system stable on load fluctuation, what got forced on the demand of the microgrid or of the island mode, it's very difficult to operate a stable power supply. There are some different options what can be in place to compensate that, but in general, as a single unit, it's difficult to operate on weak gas in island mode. Okay, let's go to the next slide. Okay, yeah, quick comparison of the injection technologies. We have our gas auto system what operates on natural gas and biogas applications. So we have, this is a picture, it's not 100% right picture, but this is a picture of the cylinder head and the combustion chamber of the piston here. That shows actually the spark plug. So we have only one spark in the center. I'll show you on other page. It's much better. So we have an industrial spark plug ignition system which ignite the gas-air mixture in the combustion chamber. So we have one spark. This one spark ignite the gas in the combustion chamber. At the dual fuel system, the dual fuel technology, with natural gas biogas application, we use the pilot fuel or the diesel in that case and spray it into the combustion chamber so that we get thousands of sparks. So the thousands of sparks, it's much more easier to ignite the gas in the combustion chamber. Yeah, it's only a quick overview. Let's go to the next page. Okay, it's a general picture. This is from Schnell as well. We have here we see here the different technologies. We have here the dual fuel system, and here the gas auto system. So we can see here this is the injector. The injector inject diesel in your case as pilot fuel into the combustion chamber. You can see here the pistons are different from a gas auto pistons. The gas auto piston is very flat on top, and the diesel or dual fuel pistons have this dip. So, and it's lying almost on the top to get a higher compression ratio into the combustion chamber. Here the gap is bigger, so it takes longer with a spark plug to ignite all the different CH4 content components, so the biogas components, in the combustion chamber. So that means the small spark plug need more time to ignite all the biogas to compare it with the spray of a dual fuel system. And there's another point, the compression ratio of a diesel engine can be higher. So we have a higher compression ratio, means higher efficiency. The higher compression ratio works on a diesel or in the dual fuel system because we have to spray 1,000 of sparks in the combustion chamber. At the gas auto system, the problem at the gas auto system, if the compression ratio is higher, or if we go higher with the compression as a spark plug gas auto system, the problem is the spark will not jump over and ignite the biogas anymore. So if the ratio here is too high, the gas will not ignite it anymore. So that's why we have on the diesel technology or dual fuel technology the big benefit that we can increase compression ratio, what means a higher efficiency. So, and special, what we keep in mind with a lower methane content. So we are much more flexible here with different gas qualities and with more electric efficiency out of this system. Schnell talking about 5% more electric efficiency. I think at the moment depends on the size of the CHP units. We talk about between 3 and 5%. Okay. Let's go to the next. Here we have a quick simulation of how the ignition works in the combustion chamber. This is a simulation. I'd like to explain a little bit. We have here the pistons underneath. The pistons, this piston here from the simulation, have 4 dips in the piston. This is the cylinder head with the spark, with the injectors. This one spray into this 4 dips, like that dip of the piston, the diesel, and in between we will have the biogas. So with this spray, it starts to ignite like 1,000 small sparks in these different dips here. It's a special profile of a piston, and this gives the better combustion speed to burn the biogas properly. Okay, I only like to show that quickly. So let's jump over to another technology of Schnell. This technology is only available, actually, let's go here, is only available for the system for 6 or 20B and BO. So the B is the dual-fuel system, and Schnell produce as well gas auto system, so biogas auto system. This system is called turbo compound technology. This turbo compound technology, it's this part of the engine. It's originally developed from Scania. Scania use it in their stationary and as well in the trucks to reduce the diesel consumption of the trucks. So we're using actually through the exhaust gas, we're using the heat from the exhaust gas as an energy content, what will be directly transferred or indirectly transferred über mechanical and clutches into the gearbox of the flywheel. We go into that a little bit deeper. Now let's swap over. Okay, this is, I hope it's big enough and understandable. It's a flow diagram of the turbo and turbo compound. So we have here the turbocharger. This is directly connected to the outlet of the engine exhaust gas. This exhaust gas turns the turbocharger and speed up the gas mixture on the other side to go back into the engine that get combusted and as exhaust back to the turbocharger. This exhaust gas has a very high temperature. So we have an exhaust gas temperature of 650 Celsius. Will run into the turbo compound. So in the turbo compound here is a separate turbine which gets turned from the actually from the exhaust gas flow and the temperature. So it's like a turbocharger half of the turbocharger, but this turbocharger, so this turbo compound,